Greetings dear friends and welcome. Till the previous video, we have been learning about scheduling tasks using the Threads API. Starting from this video, we will learn about various ways of scheduling tasks using the Executors framework. Now, as always, for executing any kind of tasks using the Executors, you need to first retrieve an instance of an executor service. Then you submit tasks to that service for execution. In the section on creating and executing threads, we looked at three kinds of thread pools provided out of the box by Executors: fixed thread pool, cached thread pool, and single thread executor. All these pools execute the tasks submitted to them only once and in an immediate kind of fashion. That is, as soon as a thread becomes available, it executes the next task. If we need to schedule the tasks for executing at some specific time in future, then we need to use any of the two additional thread pools provided by the Executors factory class: the single thread scheduled executor and the scheduled thread pool. As the names specify, the first one executes scheduled tasks using a single thread only, while the second one can have multiple threads for the same. So technically, the first one is not a pool. You need to call the new single thread scheduled executor and new scheduled thread pool methods on the Executors class to get these two respectively. These two methods return an instance of scheduled executor service interface that in turn extends the executor service interface. So everything that you could do with the executor service can be done using the scheduled executor service too. Scheduled executor interface adds four methods to the mix: two overloaded schedule methods, schedule with fixed delay, and schedule at fixed rate. Out of the two schedule methods, one of them schedules a runnable and the other one schedules a callable for one-time scheduled execution in future. Callables cannot be scheduled for repeated execution. That is why the schedule with fixed delay and schedule at fixed rate methods are not overloaded. They accept only runnables. All the four methods accept only a delay for specifying the time when the task should be executed, and no exact time is allowed to be specified. This is in contrast to the Threads API, where you can specify either the exact time or the delay for scheduling tasks. Now, all of these four methods return an instance of scheduled future interface. This interface can be used to query and control the execution of particular tasks. The scheduled future interface does not have any methods of its own. It extends two interfaces, delayed and future. We have been using the future interface for many of the functionalities provided by the Executors framework, whereas the delayed interface is new for us. It has only one method, getDelay, that takes a time unit parameter. It returns the remaining delay for the next execution associated with the task at hand in the given time unit. This method is the Executor's counterpart of timer tasks scheduled execution time method. However, instead of returning the exact next scheduled execution time, it only returns the remaining delay till the time that task is going to be executed. But the caller of this method can never be sure of the exact time of execution, because when the method returns, it will return the remaining delay according to that particular moment of time when this method is called. It is quite possible that due to thread dynamics or other reasons, when the returned value actually reaches the caller, some more time may have passed and the received value no longer represents the remaining delay accurately. After receiving the value, the caller may want to do something with it, but again, due to thread dynamics or other reasons, it is possible that when the code that uses the delay value executes, some more time may have passed by, and so the delay value becomes even more stale. Lastly, the accuracy of the returned value also depends upon the time unit that you have specified. Internally, the delay value is calculated in terms of nanoseconds. In our day-to-day coding, we typically use the milliseconds and seconds units only. Now 1 millisecond has 1 million nanoseconds. If you have specified the time unit as milliseconds, then the nanoseconds will be converted to milliseconds and a whole value will be returned. Obviously, any remainder number of nanoseconds left after dividing the internal delay value by 1 million will be discarded. This means that the error in the return value will be between 1 and 999,999 nanoseconds, or approximately 1 millisecond. Similarly, when you specify the time unit as seconds, then the error may be approximately 1 second, and so on. In light of this discussion, you should not treat the delay value returned by the getDelay method to be an accurate reflection of the exact time when the next execution of the task is scheduled. There will always be some amount of error associated with the calculations in which you use the delay value. That's all about the introduction to scheduling tasks using executors. In the next video, we will look at how to actually schedule tasks for one-time execution using the executors framework. Till then, take care and bye.